Optimization, max revenue. A commuter train carries 2,000 passengers daily from a suburb to a large city. The cost to ride the train is $7 a person. Market research shows that 40 fewer people would ride the train for every 10-cent increase in fare, and vice versa. 40 more people would ride the train for every 10-cent decrease. So anytime the price changes up 10 cents, 40 fewer people ride. Anytime it goes down 10 cents, 40 more people ride. If the capacity of the train is 2,600 people and carrying fewer than 1,600 passengers means costs exceed revenue, what should the railway charge to get the largest possible revenue? What are our parameters to this question? Yes. Fewest amount of people we can have as a business is 1,600 people. So we know whatever we denote our thing is, let's say it's going to be X. It needs to be between 1,600, and the train at safety can only carry a max 2,600 people. Okay? Page width. Okay. So, how do I make a question of this? Revenue. Okay, let's think of revenue. Revenue in terms of X. Revenue is going to be equal to the amount we charge, so our sales price. Right? So if I charge $50, it's $50, and my revenue is all the money I get in multiplied by our sales price multiplied by, anyone know? How many people buy stuff from me? Okay, so amount of sales. Is there any other word we can use for that? Amount of sales. Yeah, we'll say number of sales. Number of sales. Okay. Okay. Now, this part's a little hard, a little trickier. Our variable X, okay, that is our parameter. That parameter is going to change. Okay, it's going to change because our parameter is not actually going to be number of people. Because our parameter you need to think of it as a ratio. What ends up happening is for every 10-cent increase, so every increase we have like that, we get 40 fewer people. Okay? So what that means is we need to think of this as some type of ratio. What it's going to be is number of 10-cent increases along with number of 40 people decreases. So in other words, we're going to try to do it in terms of price. It's going to be 0.1x. Because we're not increasing prices by 5 cents, 6 cents. We're only doing 10-cent increments. Okay? Only 10-cent increments. So every time we do that increment change, if we do 2 increment changes, how much money has it gone up or down by? 20 cents, right? But we've only done 2x in that case. So I want you to think of it like that. Our sales price, the original sales price is $7. And we're going to talk about it as increases, okay? $7 plus 0.1x, depending on what our x is. We know if it's negative, things are going to go the other way, which is good, because when we do number of sales, well, right now, what are our sales at right now? 2,000. There's 2,000 people. And every time there's a 10-cent increase, that's positive. We're going to go to negative how many? Negative 40x, right? If there's only one increase, it's a change of 40. If there's a 2-time increase, our price changes by $20, but then decreases or increases by 80 people. So our x is kind of like our ratio for this. So this is our question. This is our revenue equation. Sales price times number of people. Yep. And our sales price is that $7 with a 10-cent increase and 2,000 people with a 40% decrease. We're going to expand and simplify to figure this out. So when we expand and simplify this, we end up with 14,000 minus 280x plus 200x minus 4x squared. Okay? When we arrange that, negative 4x squared minus 80x plus 14,000. Here's our equation. Revenue in terms of x. Now, our revenue in terms of x is going to change a little in terms of our parameter. Okay? Remember that our parameter is a ratio. So in order to solve this ratio, we need to think of when revenue is going to be less than 0. Okay? Or at least when it's going to exceed our costs. 1,600 people. Whoopsie. What are our options for 1,600 and 2,600 people? Well, we know that if we drop, so really what that is number of sales. This is the important part, number of sales. We know that we can't be for number of sales. We have to be above 1,600, so our 2,000 minus 40x. And we also know that we have to be less than 1,600, 2,000 minus 40x. These are our true parameters, okay? We need to solve this. When I move 2,000 to the other side, I get negative 400. All right, yeah. Negative 400 is less than negative 40x. And when we divide by negative 40x, 10, right? 10 has to be greater. Because we divided by a negative, the sign flips. We have to be less than 10. So we can't have more than 10 increases. Otherwise, we're going to have less than 1,600 people on the train. The price goes up by 10, what was that? $1. Price goes up $1. Thank you. Price goes up $1. We're right at our maximum. Anything more than that, we don't have enough people riding this train. It's not even worth it to run the train. The other one is 600 greater than negative 40. You have to be less than, sorry, negative 40. When that switches, x has to be greater than negative 15. We can't decrease our price by more than 15 increments because then we'll have too many people riding the train. We'll have over 2,600 people riding the train. So our new parameters are now between x needs to be greater than 10. Less than 10. But greater than negative 15. Those are our ratio parameters. Remember I told you those were going to change? We just set them out so we had an idea of passengers. So now that we have those parameters, we have our equation. We need to find max revenue. In other words, we got to derive, set the slope equal to 0. So we're going to find r prime x. When we derive this, the 2 comes down, we get negative 8x minus 80. That's our derivative of this function. We set it equal to 0. Negative 8x minus 80. 80 equals negative 8x. Negative 10 equals x. There's our turning point. At negative 10. In other words, a decrease of $1. A decrease of $1, which falls in our parameters, 10 and negative 15. That's fine. So we need to test r at x when x is equal to 10, negative 10, that's kind of in order, just reversed, and negative 15. Our r at x equation was negative 4x squared minus 80x plus 14,000. Well, when r is at 10, we get negative 4 times 10 squared minus 80.
Can the following students please come to the main office? Pierre Basta, Josu Galagas Benagas, Brittany Jones, Kayon Kim, Michelle Natividad, Shali Nixon, and Laksana Vijayanathan.
Just writing out our parameters while they talk there. 80 minus 15 plus 14,000. Assuming you could carry all of these out, R at 10 gives us $12,800 revenue. At negative 10, we get $14,400 revenue. And at negative 15, we get $14,300 revenue. So again, it just so happens that our turning point of negative 10 gives us a max revenue. Okay? So if that's our max revenue, they're saying we need 10 or x to be negative 10. our R at X when X is negative 10 will be $14,400. And our sales price and amount of people, important to know, remember sales was equal to $7 minus 0.1x, well, our new sales price is $6, and our number of people, number of peeps, like that one, number of peeps, sorry, this is a plus, $6.90, no, it's a dollar decrease, it's $6. And our other one was, number of peeps was 2,000 minus 40 x. Well, when we plug negative 10 into that, we're going to increase by 400 people. We'll now have 2,400 people on the train. A lot of work. Setting up the question being the hardest part about this.